dy over dx, quiet please, equals 6x squared plus 6x. dy over dx is a fancy way of saying general slope tangent, correct? That's just the general slope tangent. You done. You sit down. All right. So we want to get y. We want to get the basic y. So remember when we found the derivative, we took the exponent, dropped it in front, and multiplied, and reduced it by 1, correct? So to the antiderivative, our first step is to increase it by 1. So we get x cubed, correct? The 6 stays here, and now we have to divide by that 3. Then plus 6x, now it's going to become squared, and we have to divide by that 2, and then we put a plus c. So now we have y equals 2x cubed plus 3x squared plus c. And the reason why we have that plus c at the back is because whenever we do the derivative of a constant, it just goes away. There's no remnants of it, correct? So we either have to leave it as a plus c, or with this lesson, we learned that if I give you a coordinate off the original, we can plug it back in for x and y and solve for c. So the coordinate is -1, 0. So I can plug those in. So I get 0 equals 2 times -1 cubed. Try. Yep. Plus 3 times -1 squared plus c. So 0 equals -2. -1 squared is 1. So plus 3 plus c. So I get 0 equals 1 plus c. So c equals -1. Now I'm not done. I just need to put it back into my equation. So I get y equals, sorry, not there. Back into my equation here. Y equals 2x cubed plus 3x squared minus 1. Okay? The next one says find the equation of the curve with slope. Slope is just the first derivative, correct? So technically, could I not just write that as dy over dx, same way as last one? Equals 2 over x cubed. And it's a lot easier to deal with if that is actually up. So I go dy over dx equals 2x to the -3. And now all I've done is rearrange it, correct? So now what if I want to actually get the antiderivative of it, or the original equation? Well, we would have y equals 2x, and what do I do with the exponent? Add 1, so it's going to become -2, and then I'm going to divide by -2 plus c. Those cancel, and I'm left with y equals negative x to the -2 plus c. And then I can plug in my coordinate to get c. So I'm going to get 4 equals -1 to the -2 plus c. So 4 equals negative, what's -1 squared? 1, and then it would drop to the denominator because it's negative. Still 1, right? Because I could write this, if I wanted to, I could write this as 1 over -1 to the +2, correct? Well, that's still just 1. So this is -1 plus c. So c equals 5. So I have y equals negative x to the -2 plus 5. Or I can drop that down and go y equals -1 over x squared plus 5. So we're moving on to the next lesson. That's just a reminder of what we did. The next lesson involves motion. So we talked about distance is the original equation. Velocity is the first derivative, and acceleration is the second derivative. If I give you velocity, acceleration is the first derivative of velocity, correct? So we always worked our way this way. But now, because we know how to do antiderivatives, we can actually go backwards, okay? So here it says, in the second unit we studied rates of change. Recall the velocity is the derivative of displacement, and acceleration was the derivative of velocity. We use derivatives to find velocity and acceleration given displacement. Therefore, we can find velocity and displacement given acceleration using antiderivatives. Find the velocity of an object whose acceleration is given by A 3t squared plus 4t, where t is greater than or equal to 0. Did I give you a coordinate?
No.
On the velocity? Because I'd have to give you a coordinate on velocity to get c, yes? I did not. So what are you going to be left with? A c. You won't be able to actually find it. I'll give you 1 minute. A equals 3t squared plus 4t. V equals, I have to work backwards, so it's going to become 3t what? 3t cubed, divided by 3, plus 4t squared divided by 2, and then we can't forget, and I say you can't forget plus c, and I forget it all the time. It's just okay. But don't forget it. All right. So v equals t cubed plus 2t squared plus c, at which I cannot find, because the only way I could find c is if they gave me an actual coordinate of the velocity. Or they said velocity at 0 seconds is 8 or something like that. Then I could use that and find c. They didn't, so this is where we're at. All right, then we're going to flip over. All right. This one says, find the displacement of an object whose velocity is that, whose initial position is 5 meters. So that means time 0, displacement 5 meters, correct? So this is off the original, yes? So I can use that to find c. Try it out. Velocity equals 3 sine t minus 5. Now we got to use our brain cells and work backwards. Sine is the derivative of what? Negative cos. Because the derivative of cos is negative sine, correct? So sine would actually be the derivative of negative cos. So we're going to get d equals negative 3 cos. I love coefficients because they do nothing. Cos t. And then minus 5 what? And you just have when you just have a constant, what does it become? What was it? It was just a t, correct? Plus c. Then we have to fill in our time and our displacement. So 5 equals negative 3 cos 0, which some people, you guys have to watch yourself because cos of 0 is not 0.
Oh, wait, so we don't put an exponent back on the cos t. Like you would to divide the negative 3 by 2. Why would you put it all 2 up?
No, it's trig derivatives. So like you want to work your way backwards. So if I say what's the derivative of negative 3 cos t, you'd say it's 3 sine t. There's nothing extra to that. And the only way you would get a division, guys paying attention, if it was like cos 2t, Brooke, then you divide by 2. Because remember, you would have multiplied by 2 in the first place. If it was cos 2t, you would do chain rule. Like if the derivative of, what would be the derivative of cos 2t? Well, it would be negative sine 2t times 2.
Yeah.
So if you actually had something in that bracket with the t, you'd have to divide by that.
So don't take the coefficient as that.
No.
Okay.
And then minus 5 times 0 plus c. What is cos of 0? 1 plus c. This goes away. And so I move that over, I get 8 equals c. So d equals negative 3 cos of t minus 5t plus 8. Okay, sometimes they use S for displacement. Enjoy that. So find the displacement and the velocity of an object whose acceleration is this, when S equals 3 meters and V equals 7 meters per second when t is 0. So on the original, S graph, which is D, you have 0, 3. And then on the velocity, you have 0, 7. So you're going to have to find the acceleration formula back to velocity with a plus c. Find out what that c is first, right? By plugging in this. Then when you get that c, you go back to the displacement formula and find the new c of that one. So you have to work your way back, getting a c each time. Try it out. So A equals 6t plus 4 If I want v, I have to get 6t. What's going to happen to the t? It's going to become a, raise the power of a 2 divided by 2 plus 4t plus c. So v equals 3t squared plus 4t plus c, and v is 7. Don't know why I kept these as c's. So the t's turn into zeros. Ah, what just happened? There we go. All right. So then those cancel off and c equals 7. So v equals 3t squared plus 4t plus 7. Don't know. All right. V equals 3t squared plus 4t plus 7. So displacement, or S in this case, equals 3t to the what? 3 divided by 3 plus 4t to the squared divided by 2 plus 7t plus c. So I get S equals t cubed plus 2t squared plus 7t plus c, and S is 3 when t is 0. When it's 0, it's nice because it usually cancels off, but you have to watch yourself when it's a trig function, because like cos of 0 doesn't just cancel off. Cos of 0 is 1, right? So you have to watch yourself. These ones, when it's a polynomial, it's nice because they just go away. So c is 3. So S equals t cubed plus 2t squared plus 7t plus 3. Finito.